Section 4.4 notes cover a couple different things. First of all, they ask you which of an ordered pair is a solution to a given equation. Pause the video and write this example down, and then we'll talk about how to do it together. What they're asking here really is which one of these, and it might be one and it might be more than one, but which one of those, when you plug it into the equation, makes the equation true. And when we plug things in, we're plugging in both an x and a y. As far as work goes, we're going to make a little table, and we're going to put the point that we're plugging in first. Then we're going to show our work in the middle. And then we're going to answer the question off to the side. Either yes, it's a solution, or no, it's not. If we start with the point 4, negative 4, we're going to plug that into the equation. So we'll have y equals, so that's negative 4 equals 8 minus 3 times 4. Let's see if that's true. Does negative 4 equal 8 minus 12? Yes, it does. So that point is a solution to the equation. The next point is the point 8, 0. This time we're putting 8 in for x and 0 in for y. Does 0 equal 8 minus 3 times 8? Does 0 equal 8 minus 24? No, it does not, because 8 minus 24 is negative 16, and that's not equal to 0. So the answer is no. Is 2, 2 a solution to the equation? We'll put 2 in for y and 2 in for x. And we find out that yes, 2, 2 is a solution to that equation. The last point is 3, 3. We're plugging that into y equals 8 minus 3 times x. So does 3 equal 8 minus 9? No, it does not. So that one is not a solution to the equation. That's one part of section 4.4, deciding if an ordered pair is a solution to the equation. But the bigger part of section 4.4 is graphing linear equations. And we're going to talk about two different methods to do this. One method is going to be to make a table. Take a minute to copy down the equation that we're going to graph. Make a table that looks like this. And make yourself a graph so that you can graph the points with me. Pause the video while you write those 3 things down, and then we'll work on this one together. As we make a table, we're going to put x values here, we're going to put work in the middle, and we'll put y values over here. As you graph these, I would always like you to pick at least one negative number, 0, and 2 positive numbers. If it's an equation like this where there aren't any fractions, you can just pick negative 1, 0, 1, and 2. The next example is going to have some fractions, and we'll talk about what you should do in that case. So if x is negative 1, y would equal 2 times negative 1 minus 3. So that's negative 2 minus 3, or negative 5. The point negative 1, negative 5 is on the graph. So we'll put a dot there at negative 1, negative 5. Right there. Then we'll plug 0 in, and we have y equals 2 times 0 minus 3. So 0 minus 3 is negative 3. The point 0, comma, negative 3 is on this graph. Then we'll plug in 1. Y equals 2 times 1 minus 3. That's 2 minus 3, so y equals negative 1. The point 1, comma, negative 1 is also on this graph. Finally, we'll plug in the point 2, and we get y equals 2 times 2 minus 3. So that's 4 minus 3, or positive 1. The point 2, comma, 1 is also on this graph. But the graph doesn't just include what's on the table, it includes everything in between and everything continuing in either direction. So at this point, you need to look for a pattern. The pattern here is up 2 spaces, over 1 space. Up 2 spaces, right 1. Up 2, right 1. For your tests, you need to graph all of the nice points. So that means we need to keep the pattern going and go up 2 spaces, over 1, and keep putting dots on our graph until we run out of room. You don't need to put the arrows, you can just put the dots. I'm putting those arrows there to show you what I'm doing. And we can also add some dots in the bottom left. We just need to reverse the pattern. Now instead of going up, we're going to go down 2, and instead of going to the right, we're going to go left. So down 2, left 1 gives us a little bit of room for some more dots. These dots, we're going to use a straight edge like a ruler or the side of a sheet of paper or something like that to make a very, very straight as you can line that goes all the way through those points. And it would keep going in both directions, so we're going to put arrows on either side to indicate that. When you try to make a graph using a table and you have a fraction, we're not going to pick negative 1, 0, 1, and 2 anymore. This time, as we try to make the graph, we are going to pick values that are multiples of the denominator. Because as we do that, we're going to get some really nice numbers out. So I'm going to pick negative 3, 0, 3, and 6. Pause the video if you haven't already and write down this new equation, make yourself a table, and make yourself a graph. And then we'll work on filling out the table together. The reason we picked multiples of 3 is because when we plug it in, now we're doing 2/3 times negative 3 plus 5. And we know that when we multiply, I'm going to make that negative 3 a negative 3 over 1, and things cancel really nicely. So I end up with a nice whole number, just 2 times negative 1, which is negative 2. But I still have to add 5 to it. So negative 2 plus 5 equals 3. 1 point on this graph is at negative 3, comma 3. Plugging 0 in is always easy because any number times 0 is just 0. So 2/3 times 0 is 0, plus 5 is 5. The point 0, comma 5 is also on this graph. We're still plugging in multiples of 3, and when we plug in positive 3, we can make that 3 over 1, and the 3's will cancel out. So 2/3 times 3 is just 2. That's all that's left. Add the 5 to it, and we get another point for the graph. Another point is at 3, comma 7. If we plug in 6, we have y equals 2/3 times 6 plus 5. 6 can be 6 over 1, and when we cross cancel, we get a 1 and a 2. So going straight across the top, 2 times 2 is 4 over 1 times 1 is 1. So our answer here is 4 plus 5, or 9. 6, 9 is another point on this graph. We want to find the pattern between the points and continue the pattern. So in between points, we go up 2 to the right 3, up 2 to the right 3. So I don't have any more room to keep going in this direction unless I go a little bit off the graph. But I can continue it in the negative direction by going down 2, left 3, down 2, left 3, and get all of the nice points. Then use a ruler or something very, very straight like the side of your binder to make a straight line through all of those points. The line does keep going in both directions, so make sure you put arrows at the ends. There are also some definitions in this section, and you can find those definitions in your packet. So if you flip to your packet, there's a page that says definitions at the top, and then it starts with domain, range, and x-intercept, just like I have here. The domain of a graph is the input values, which are typically the x's in the equations that we talk about. The range are the output values, and the output values are typically the y's. The x-intercept of a line is where the line crosses the x-axis. So if I have the graph of a line, wherever it crosses the x-axis is the x-intercept. Since that point is right on the x-axis, it is going to have a number for x, but it's not going to go up or down any, so it's going to have a 0 in the y-coordinate. The y-intercept will be where the line crosses the y-axis. So if I have the graph of a line, wherever that line crosses the y-axis is the y-intercept. Points that are y-intercepts don't go any left or right, but then they do move up or down. So they have a 0 in the x-coordinate and then a number for the y. To find the x-intercept of an equation, we're going to use the fact that it has a 0 in the y spot. So we're going to put 0 in for y and solve for x. We'll do an example of that in a minute, but when we do, our final answer is always going to be an ordered pair with a number in for the x and then a 0 for the y. To find the y-intercept, we're going to put the 0 in for the x. And solve for y. The final answer will always be an ordered pair, and it'll have a 0 in for the x, and then the number that you find for the y. Two quick examples of graphing a line using the x and the y-intercepts. The first one, we're going to graph x plus 2y equals 6. I'm going to find the x-intercept first. And my note says that I'm supposed to put a 0 in for y. So I'm going to say x plus 2 times 0 equals 6. and I need to figure out what that x number would be. The x is 6. So my final answer is 6, 0. 6, 0 is the x-intercept. It's where this line is going to cross the x-axis. The y-intercept, I need to put a 0 in for x this time. So I'm going to have 0 plus 2 times y equals 6. So I just get 2y equals 6. And if I divide both sides by 2, I find out that the y-intercept is 3. My final answer is an ordered pair. 0 in for x, 3 in for y. And 0, 3 is on the graph. Now we're not just going to connect those to make the line, we're going to find the pattern. The pattern is going down 3 and over 6. So we're going to keep that pattern going. I don't have enough room to keep going down 3 and over 6 more without running out of room, but I can reverse it and go up 3 and backwards 6. 1, 2, 3, 4, 5, 6. And maybe one more time, go up 3 and backwards 1, 2, 3, 4, 5, almost 6. Use a ruler or something very, very straight and connect those points to make a line. It is a line that keeps going, so make sure you have arrows at both ends. In this case, the x and the y-intercept were both very nice numbers. On this next example, they're not both going to be nice numbers, but let's try it anyway. To find the x-intercept, I need to put 0 in for y. So I'm going to have 3x plus 2 times 0 equals 9. 2 times 0 is just 0. So I get 3x equals 9. And x equals 3. My final answer is an ordered pair, 3 for the x, 0 for the y. That point is nice, so I can plot it on my graph at 3, 0. When I find the y-intercept, this time I'm going to put 0 in for x. So 3 times 0 plus 2y equals 9. That's 0 plus 2y equals 9, or just 2y equals 9. And this isn't quite a nice number. It's 9 halves, or 4.5. So it's going to be a little bit tough to graph. First of all, my ordered pair would be a 0 for the x, and then 4.5 for my y. As I graph it, I'm going to be halfway in between. I'm not going to be quite at 4 and not quite at 5, but halfway in between. Now as I count out my pattern, I'm going down 4.5 and over 3. So when I go down 4.5 again, I'm going to be halfway in between again, and then over 3 spaces for my next stop. And if I go down 4.5 again, halfway takes me so I'm right on a line, and then 1, 2, 3, 4 more spaces. So there's 4.5 down and over 3. And reverse the pattern in the other direction. Go up 4.5, 1, 2, 3, 4.5. And over 3. Use a ruler or something straight to connect those points. And it does keep going forever, so make sure you have arrows on either end. In this section, you learn 2 ways to graph a line. First, by making a table, and then second, by using the x-intercept and the y-intercept. The homework in this section are more pages from your packet.